Hello, everyone, and welcome to Rational Expressions and Equations Lesson 5. So today we're looking at multiplication of rational expressions, which is awesome. This is kind of the nicest one, I think, and I think you'll have a little bit of fun with it. So let's jump in. So it says here, review multiplication of rational numbers. Recall these steps for multiplying rational numbers. Consider the factors of the numerator and the denominator. If there are factors common to the numerator and the denominator, reduce by dividing out the common factors or canceling the common factors. Multiply all the numerators together and multiply all the denominators together. A little bit of a wordy process there, but we'll just jump in. So just a quick reminder, multiplying fractions. So multiplying fractions is one of the nicer ones. In this case, you can just multiply your numerators together. 7 times 1 gives you 7, and the denominators together, 10 times 5 gives you 50. And that's pretty much it. So I'm just going to zoom in a little bit because I think we're going to have lots of crossing out to do. So we're going to use this idea. But before we do that, we're going to use this idea on some larger terms. So if you look at A here, you can see we have 12xy divided by 4z multiplied by 3xz squared over y. So we are basically going to multiply the top together and multiply the bottom together and then create one term. So with that in mind, what you can actually do is start canceling things out, right? We know that, for example, if we have a y here in the bottom, I'll just highlight it so you can see. If we have a y here and a y over here, even though they're part of two different terms, when we multiply everything together, there's going to be one y in the top and one y in the bottom. So before we even multiply, what you can do is you can just cross off. Okay, there's a y and a y, we'll cross it off. You can see that we have a z here and two z's, so I'll just cross that off. So we have one z in the top. And then you can even deal with some numbers, right? So here we have 12 divided by 4, and we know that reduces to 3 over 1, or just 3, right? So that becomes 3, that becomes 1. So now when we go to write this down, we have 3 times 3, which is 9. We have an x left right there, and another x, so we get x. Sorry, that's a bad x. Let me rewrite that. X squared. And we have a z. And that's it. There's nothing else in the bottom. We do have to state the restrictions. So maybe it's better to do that before we cancel everything out. That's a better strategy. I apologize for skipping that part. So if we look at the bottom, we know that z can't equal 0 and y can't equal 0. So maybe we'll do that first next time. And that's your answer. And the next one, a little bit bigger, a little more complicated, but the first thing we're going to do is state our non-permissible values. You can see that we have A, B, C, and D here, and they're all multiplied together. So basically A can't equal 0, B can't equal 0, C can't equal 0, and D can't equal 0. And now what we can do is we can start doing our cancellation of everything. So the first thing I'm going to do is maybe reduce this 35 over 40. If I divide both 35 and 40 by 5, then I can reduce that fraction to 7 over 8. And then you can see that we have a 7 here and a 14 there. So we can reduce that 7 over 14 to be 1 over 2. And then I don't think we can cancel any of the coefficients out anymore or reduce them. So now let's start dealing with variables. I have 2 a's in the top and 3 a's in the bottom. So I'm going to cancel these ones out, and I will just make that an a. I have, oh, it looks like I have a b squared over a b squared here, so those can cancel out. I have c4 on the top, and then I have c here and a c here, so I can cancel both of those c's out and basically turn that into a c squared. And I think that's all we can do. So now, if we were to rewrite the top, we have 5c squared multiplied by 1b. So the top is going to be 5b c squared. And in the bottom, I have 2 multiplied by 8, so that gives me 16. I have a d and I have an a, so a d. And that's it with our non-permissible values. Yeah, so it's going to get a little bit more complicated, but not too bad. So now we're going to look at single variable rational expressions. So you can see here we've got 2 questions. Both of them are already factored, which is really nice. So the first thing we want to do is state our non-permissible values. So we say that x can't equal +2, -3, 0, or -1. And then we can just start canceling things out. I've got an x plus 1 here and an x plus 1 here, so those cancel. I have an x plus 3 and an x plus 3, so those cancel. And I'm left with 2 on the top. And on the bottom, I'm left with x and x minus 2. So x times x minus 2. There we go. That's our final answer. So on the next one, we have to do a little bit of factoring, but nothing too tricky. So what I'm going to do is rewrite this equation. So let's deal with the top left term here. We have 4x plus 16. So we can factor a 4 out, and we're left with x plus 4. And in the bottom, we have 14x minus 7, so I can factor a 7 out, and I'm left with 2x minus 1. And then we're going to multiply by 2x minus 1. We can't cancel that out. And then over here we have x plus 4 squared, which means we're going to have x plus 4 times x plus 4. So now I can say that my non-permissible values are going to be x cannot equal 1/2 or -4. And I can start canceling things out. So looks like we have an x plus 4 and an x plus 4. We have a 2x minus 1 and a 2x minus 1. So our final answer is going to be 4 divided by 7 times x plus 4, where x can't equal those values. That's it. So the canceling is pretty good. It can take a pretty complicated equation and make it really nice and simple, which makes everyone's life a lot easier. So a couple more before we end the video. I have 2m cubed minus 4m squared, all divided by 3m squared minus 9m, all multiplied by m squared minus m minus 6, divided by m squared plus 4. So let's just rewrite this and let's factor all the terms. So top left, we can pull a 2m out, or 2m squared actually. And we're left with m minus 2. In the bottom, we can pull out 3m. And I'm left with m minus 3. And then that's all multiplied by, well, let's do the top term. The top term is a trinomial with no constant, so we can factor it by inspection. So we're looking for 2 numbers that multiply to -6 and add to -1, which will be -3, +2. And then in the bottom we have m squared minus 4. That's a difference of perfect squares. So we can factor that. M squared is m times m, and 4 is 2 times 2. One's a positive, one's a subtract, or a minus. So now I'm going to state my non-permissible values. M can't equal 0, positive 3, and plus or minus 2. And now I can start canceling things and rewrite this. So we have an m minus 2 and an m minus 2. We have an m minus 3 and an m minus 3. We have an m plus 2 and an m plus 2. We have an m here, so I can cancel that out. And I think that's it. So now we can say that's equal to 2m over 3, where m can't equal 0, 3, plus or minus 2. Not so bad. It's when we get here that things get a little bit interesting because we have to do a lot of factoring, but you guys are totally capable of doing that. So I'm going to rewrite this. So the first trinomial in the top is has no constant in front of the a squared term, so we can factor it by inspection. Two numbers that multiply to 15 and add to 8 are going to be a plus 5, a plus 3, and then the bottom we have 6a squared plus 21a plus 9. So what we have to do, I'm just going to scroll over, is we are going to do this by decomposition. So we 6. Oh wait, before we do that, we can actually factor a 3 out. So we have 2a squared plus 7a plus 3. That's going to make our life a lot easier. So now we're going to go 2 multiplied by 3. That gives me positive 6. So two numbers that multiply to 6 and add to 7 will be 6 and 1. So I can split that 7a into 1a plus 6a. And then I can do my factoring by grouping. So let's just use square brackets. So I'm going to factor the first brackets there, and I can pull out an a. And I'm left with 2a plus 1. And in the second brackets, I can pull out a positive 3. And I'm left with 2a plus 1. Which means I'm on the right track, because now I can say this is 3 multiplied by 2a plus 1 multiplied by a plus 3. So I'll come back here and I'll fill that in. 3, 2a plus 1, and it was a plus 3, yeah, a plus 3. Perfect. Now let's factor the next half. So in this top of the second term, we have, sometimes if I touch my screen, it just goes crazy. We have a minus 4a cubed. So I'm going to just factor that up here, a minus 4a cubed. So I can factor an a out, and I'm left with 1 minus 4a squared. And then you can see that that binomial is a difference of perfect squares. So we can write that as a, and then we do 1 times 1 is 1, and 2a times 2a, 1's a plus and 1's a minus. So I can write that down here, a, and then 1 plus 2a, and 1 minus 2a. And then the last one, I'm just going to scroll down a little bit. We're going to do another decomposition here. So we want to factor this last term, the denominator of the second term, which is 2a squared plus 9a minus 5. So if I swing that 2 times negative 5, I get negative 10. So I'm looking for two numbers that multiply to negative 10 and add to positive 9. So maybe plus 10 minus 1. So I can rewrite that as minus 1a plus 10a minus 5. We can factor by grouping. So in the first one, I can pull an a out, and I'm left with 2a minus 1. And in the second one, I can pull out a positive 5, and I'm left with 2a minus 1. So my answer is going to be 2a minus 1 and a plus 5. Perfect. So now we're here. We factored everything out, and now we can state our non-permissible values. So we can say a cannot equal -1/2, -3, +1/2, and -5. And we can start doing some canceling. So a plus 5 and a plus 5 cancel, which is great. A plus 3 and a plus 3 cancel, which is awesome. 2a plus 1 and 1 plus 2a are the same. It's because they're both positive values, so you can cancel those out. And then what we're left with are these two factors here, 2a minus 1 and 1 minus 2a. So what we have to do is, in order just to switch the order of this, we have to factor out a -1 so that we get 2a minus 1. So remember that there's a -1, and then I'm going to cancel this out with this. So now in my top, I have a -1a. So I'm left with -a. And in the bottom, the only thing I have left is that 3. So -a over 3 is our answer. So I think the canceling and the factoring is going to be good for everybody. Just try to keep it neat and tidy so that you know what you're left with. Because if you don't know, if it's so messy you can't see what's left, you're going to miss a term or miss that negative sign or miss that 3, then your answer is going to be different. But that's it. Hopefully you enjoyed this lesson. Thanks for watching. Don't forget to like and subscribe.